Okay. Okay. Mahatma Gandhi is to 1930. Is Greta Thunberg is to 2019. Question mark is to 1982. What is the answer? Hypocrites? How do, Nelson Mandela, 1982? Not a bad guess, but other guesses? Yes? So what are we talking about? What did Mahatma Gandhi have to do with 1930, which Greta Thunberg had to do with 2019? No, she didn't. Greta Thunberg didn't do Dandi March in 2019. Okay, so let me give you a hint. It was some award. Nobel Peace Prize, Greta Thunberg didn't win as of yet, but you're on the right track. Survey for Peace, on the right track, but not correct. Anyone who does quizzing? Right for Revolution, no. So okay, so it's an award. Time magazine, okay. So the Person of the Year award. Mahatma Gandhi won in 1930. Greta Thunberg won in 2019. Who won in 1982? Which person won the award? No, it wasn't Indira Gandhi. Guesses? Alan Turing was not living at that point of time. Okay, it could have been awarded later also, but he was not living at that point of time. But you're not far. Alan Turing is not far from the answer. Nope. Nelson Mandela was already said. Wrong answer. Ada Lovelace, no. All of you are getting closer, but not very close yet. Sorry? No, it wasn't Anne Frank. Martin Luther King, no. So it has to do something with this course. So did someone just check on the phone? Yes. So the Person of the Year award in 1982 was the computer. So that is why this was a confusing question. This was a misleading question. It wasn't a person as such, it was a computer. And that's what the topic of this course is. So we've seen computers all around us. Do people remember this game? Contra, right? So we have all played this game, and I still remember that. So there are certain powers that you didn't want to actually get. So like some were good powers, S was good, M was something was not good, right? You would have to expand your powers. So what does computation have to do with this game? What do you think? Why am I bringing this up in a computing course? This is a game, right? Why am I bringing this up? Sorry? We didn't really play this on a computer, right? If you remember, we used to play it on a console. We used to connect it to a TV with a separate AV wires, right? You'll have to put a red wire and a white wire. It is also in a some sense, it's also a computing device. And we're going to consider a few characteristics which are going to define something related to computing. So one, we're discussing that there were certain inputs that you used to give to the game, right? You would have to have your controller. You would press the different keys, or you would press left, right, up, down. Right? You're giving certain instructions, certain inputs to the game. There used to be also certain outputs from the game, right? Your score would get updated. Your level would get changed. You will either die or go on. The graphics will get updated. The sound will get updated. What are the other kinds of outputs you can get from this game? Mostly this, right? Now you've given certain inputs. You have certain outputs. What do you think is relating this input to the output? There is certain kinds of steps being taken, right? If you press go forward, the character moves forward, right? How does the character move forward? Right? There has to be certain kind of program, or there has to be certain instructions given that when you move the character to the right, you press the right button, the character moves to the right. Or when you pick up this particular power, M power, you will have certain kind, your gun will behave in a slightly different way, right? So all of this is already programmed, or it's a set of instructions which is stored, right? So we're looking at these three common steps, or these three common things that we'll see in different kinds of computing devices around us. We'll see certain kinds of inputs that you give to a device, the certain steps of sequence of steps or some procedures which are followed, and then certain outputs that you get out of the device. Right? So because this course will deal with a lot of programming, I thought that I'll show you a very quick demonstration of how you can yourself create some games. This game is copied from the internet. I haven't created it. I have copied this game, and this game is in a language called Python, which we'll be studying in this course. So what game is this? Snake game, right? The objective is to eat these small squares, and then the snake will become bigger. Eventually the snake will eat itself up, right? So if you're not convinced that this is something you can do, let me just show you the code for the program. So some of you might not have taken any amount of programming. You might not have seen any code before. This might be the first time you're looking at a computer. Don't worry. This is just an introductory lecture. We'll eventually get you to this stage. Maybe not in this semester where you can build games, but if you're interested, perhaps you can still. So let's just see if we can show you this game. So I said that every program or these computing devices, they will deal with two kinds of things. Take some input, give some output, and then also have some certain steps which move the input to the output, right? Which use the input to give you some output. So without getting into any details, so if you see that this is drawing some rectangles, right? It's saying that draw dot rectangle, right? Of course, you don't understand all the context yet or all the syntax yet, but just think of it as you can create that game out of some rectangles, and a rectangle is being created based on certain conditions. You see, if you press the mouse button down, if you give a certain kind of an input, or if you do the mouse button down, then certain other things will happen in this program. Right? This is how the snake is moving. So all of this is certain logic which allows the snake to move, and then you'll also have to have some logic or some sequence of steps. What happens when the snake eats the object, eats the fruit, right? Certain things will have to happen. Of course, at this point, as I mentioned again, you don't need to know anything about this particular piece of code. This is just to show you that games are created using programming, using the concept that we learn in this course. So we want to keep this lecture interactive. If there are any questions, you can please stop me at any point. Any questions at this point? I'm surprised. I was expecting someone to ask that how much time will it take you to create a game like this? No one wants to ask these questions. You just want to play games, don't want to create games? Yes. Okay, so that will come. That will come. I just want to introduce the certain things first, and then we'll come to the what will you learn at the end of this course. Yes, other questions? There was one question there. Yes. Will you study watch module? BUI. PY game, Py game. I see. Okay. So the question is, will you study? I'm just repeating the questions because we're also recording. Will we study the Py game module? No and yes. So you will learn the concepts which will allow you to pick up any new module and create games or do various kinds of things, but we will not be teaching that explicitly. We will be focused more on the basics, which you can use further on the course to do various kinds of interesting things. We'll see more interesting things you can do with programming and computing. Yes, you have a question? Other questions? Yes. Can you make a 3D game with this? I don't think with this module, but there are other modules you can use to create 3D games. So in fact, all the games that you see, so what are the popular games that you play? How many play FIFA? Counter-Strike, FIFA, Call of Duty, right? All of them are programs written in certain environments. But these are very specialized environments. These will take a lot of time to get used to be able to create games there. It's easy to play than to create such games. Other questions? Okay. What program do you see now? What is the software that I'm showing in the screen? it's some kind of it is similar to Microsoft Word or Open Office, right? It's an Office suite, right? So this allows you to write this allows you to do some spreadsheet work, create presentations. Now, again, this is a program which has been written by someone, right? So Microsoft created the Office suite, and then Apple created the Mac Office suite. So all of these are also programs. This is to show you that you are already dealing with a lot of programs around you, right? So in fact, the recording for this lecture is currently going on over Zoom. It's a program, right? You have this projector, which is displaying something on the screen. It's a program. It takes a certain amount of input. It gives a certain amount of output. There are some stored procedures, right? So we've been dealing with a lot of programs in our, so you have the biometric machine, which would be soon shared with you, right? The biometric machine is also having some program in it. You give in an input, which is you give in your thumb impression. It gives you certain kind of output. It registers your thumbprint. It checks whether or not it's present in the database. And then it marks the absent or invalid, something like that, right? So we've been dealing with a lot of programs already, but it's just that we don't think about them. So in this course, we want you to think about programs. So in essence, this is an interface which is presented to you, right? You have an interface for Microsoft Word. You type something in, you give a certain amount of input, it gives you a certain amount of output. You type something on the keyboard, something appears on the screen, right? So there has to be some logic again, which translates your typing on the keyboard to something you see on the screen. You press Control S or Command S in Mac, that saves the current Word file, right? So all of this has certain logic which is embedded. But let's say if we were to use our favorite Python to create a GUI. So I'll be showing you a very small user interface, but this is nonetheless still a user interface. This takes in the temperature in Celsius or Fahrenheit and converts into the other unit. So let's say if I were to tell 37 Celsius is about 98.6 Fahrenheit. What is special about 37 Fahrenheit, 37 Celsius body temperature? So has anyone wondered why we generally report the body temperature in Fahrenheit and not in Celsius? So whenever you get fever, do you say that I have 37 Celsius fever, or do you say that I have 98.9 fever? Think about that, right? But in this program, I can just do the reverse also. So I can just take 100 Fahrenheit, convert that to Celsius, right? It's a very dummy program, very small program. So all of you already know the formula for conversion between Celsius and Fahrenheit, right? So again, if we just look at the program without you having seen any Python program, assuming some of you have never seen any programming language, but let's still see if we can figure out some logic, right? So you would expect some 5/9 into x minus 32 kind of relationship between Celsius and Fahrenheit, right? So let's just see this program. Okay, so you want to convert Fahrenheit to Celsius. You take the temperature in Fahrenheit, subtract 32, multiply by 5/9, you get the temperature in Celsius. Right? So this is a formula already known to you. Right? So again, you're seeing that you have to have certain kind of logic or certain things which you want to execute, right? And based on the inputs, you are able to do this logic or able to do this transformation from Fahrenheit to Celsius and Celsius to Fahrenheit. So of course, the program needs to know whether you've chosen Celsius or Fahrenheit, right? And it also needs to figure out what is the input that you've given. So this program is containing all of those things. It's not a very big program, but it contains all of those things. So for example, we saw that in a drop-down list, we had Celsius and Fahrenheit. And in this line of code, we can see that drop-down list, it's a variable, and it's storing that somewhere. Okay. So let's go ahead then. Other questions at this point of time? All of us have definitely seen Google, right? We use it every day for doing our searches. Does anyone know how search works on Google? So does it work by someone sitting behind the desk at Google in an office? And so as soon as you type computing course, IIT Gandhinagar, someone sitting with an encyclopedia opens up the page and figures out that what results should be retrieved. Does it happen that way? No? Then how does it happen? What do you think? One at a time, yes. Okay, you can go ahead. Okay. Okay. Okay, so you give a search query. Let's say you give the query computing IIT Gandhinagar. Now, Google and similar companies will have a database of millions and trillions of web pages, right? But does it return you millions and trillions of web pages? No, that's not useful to you. So it has to give you your results in a certain sequence, right? It says it's giving you results in decreasing order of importance, right? Of course, you'll also see that there are some ad results also. That's how these companies also make revenue. So, and they also have to serve ads which are relevant, right? Let's say if you're writing about computing IIT Gandhinagar, and if the ad is to, let's say, sell you a football, the ad is not very relevant. So again, they'll have a program which figures out that what advertisements they should be giving to you based on the context, based on the queries that you have searched, and based on your geography, etc. So this is also a program. It's actually a combination of multiple programs, huge programs which are running behind. Now we can also create a website using simple programming languages. Right? I can show a very simple demonstration, which it's a very small program which creates a website. It's not really a website, it is just a static website for now. It's not allowing you to do any search, etc. So this is this is a website which is running on right. So this is something which is now opened in a browser. So I previously showed you a demonstration of something which opened as a graphical user interface, which is like the kind of applications you see, Microsoft Office, which open natively in your operating system. But then I'm showing you an application which is opening in the browser. Right? So many of the applications today that we see open in the web browser rather than they open in the as native applications. Okay, so then we can also use programming languages for doing various kinds of data analysis, right? So in fact, I got a roll sheet yesterday, and I was trying to have some fun with your data sheet to try and figure out if there are certain patterns I can discover. So let's just go through that. Again, you don't need to bother about the code specifics. I just want you to show that what is possible if you know programming, right? So I just read an Excel file. This is now giving me a spreadsheet-like interface, right? Have all of you used a spreadsheet? Yes, you would have probably used Google Sheets or Microsoft Excel. But even if you've not used a spreadsheet, nothing to worry at this point of time. Think of it as it is containing various rows and columns. In mathematics, you would have studied a matrix, right? So think of it as a matrix containing certain number of rows, certain number of columns. In this case, the rows correspond to the different users in this batch, students in this batch, and the columns are corresponding to the different attributes, such as roll number, name, program name, discipline, right? So when I got the spreadsheet, there was another additional field, which was your email IDs, but I don't see that here. Why do you think that's the case? Sorry? I have actually not filtered it out in this. I have actually deleted that column. Anyone knows why? Why? What kind of a privacy issue? That the spreadsheet is only with me, right? And I trust myself, let's say. The class is being recorded, right? So I don't want to be, so it's not very difficult to now take a screenshot and get the data out of it, right? But I thought that it's okay to still have your names on the recording. That's because all of that may already be publicly accessible, right? So we have these various 280 students, right? So I wanted to answer some questions. And I can access the names of all the individuals using a single line of code. So I just wanted to see what is the length of the names, right? So for example, the first student, Aditya Roy in this, the length of the name is, and I'm counting both the first name, last name, 1, 2, 3, 4, 5, 6, 7. I'm counting spaces also for now, 9, 10, 11, 12, right? So it's 12 characters, whereas the second one is shorter. There are, of course, slightly longer names also, like Yash and Darshan, Tejas. These are slightly longer names, right? So before we look into any of the analysis, what do you think is the average length of the name? What do you think? would that number be? 5, 10, 15, 20, 30, 45, 12. Okay, how many think it's between 5 and 10? How many think it's between 10 and 15? Okay, that's the majority. Between 15 and 20? Between 20 and 25? Okay. So let's just actually see what this distribution turns out to be. And again, while this might seem like just a one line of code that I've written, this generally takes some years of practice to be able to write that one line of code, right? To be able to figure out that what is that we want. So it turns out that the maximum length, the length for which there are maximum number of students is somewhat between 10 and 15, which is what we thought, right? So at this point of time, I'm trying to actually wonder if I look at this histogram. Does everyone here know what a histogram is? Anyone here who's not seen a histogram? Not seen a histogram before? So histogram, just think of it as it figures out the x-axis is telling you the length of a name. The y-axis is telling you how many students have that length. So length 9, there is, let's say, 1 student. Length 10, there is 1 student. Length 11, there is, sorry, not 1, about 18, 19 students. Length 11, there is about 32 odd students. Length 14, there's about 75 odd students. Right? So this is what a histogram is trying to capture. So I'm genuinely curious at this point of time that there are these bunch of students whose names appear to be a bit short, 10 or few characters, right? So who do you think these could be? Why do you think there are students who have shorter names? Okay. So someone of you is saying that maybe their first names are only present, their last names are not present, right? I actually never thought about this when I was doing this analysis. I was thinking that maybe there are some people who have shorter names. So in fact, there is only one person who has a short name, short first and last name in this list. Actually, the others are the people who have given only the first names in the spreadsheet. So that person who has given whose name is actually short is Om Gupta. Do we have Om Gupta here? No? Okay. So the others have just given their first name, right? So such kind of analysis helps you to figure out that is it actually an issue with the analysis? Can you draw some conclusions out of this analysis or not, right? Again, if I had to ask a human being to do it, so this is the importance of computing. If I had to ask a human being to figure out these things which I'm doing, it might take them half an hour, 1 hour. Right? They may get bored. They have to look through the spreadsheet of 287 names, 5 columns, but it just takes me 10 seconds to run this through a program, right? So this is showing you strength of computers, strength of programs. They can do such repetitive complex tasks very well. So this is now confirmed that indeed there are people who have shorter names according to the logic that we'd use, but they're actually not shorter names. There's just the set of people who are given only the first name, right? So now let's maybe look at some other questions. Do we have any repeating names? Have you guys figured that out already? Okay, what is the most common repeating name? Aditya, how many? 8? Okay, any other repeating name? Siddharth, Aditya, okay. Mayank, okay. But again, I am lazy, so I don't want to get the wisdom of the crowd, or I don't want to go through the spreadsheet myself. Let's write a program, right? So I've just written a single line of code which gives me the counts for the different names, right? How many times does a certain name appear? And it appears that Aditya occurs once, Aditya Roy occurs once, Pradeep Kumar once, Pranchu once, Pranjal once, so on and so forth. But this goes against the logic that we just discussed, against the discussion. We said that there are multiple Adityas. What is wrong? So is the program wrong? No, the program is not wrong. What we have instructed to the program is wrong. If we ask the program to tell me the names of all the individuals, how many counts do we have for individuals? None of the individuals' full name is repeated. So while we have multiple Adityas, there is a single Aditya Roy, right? So if we give the wrong input to the user and we expect to get the right output, then that is not going to happen. right? So that's another thing we need to be careful about programming and computers in general, that they work as the input that you give to them, right? They don't understand what is in your head. They understand what you've written in the program, what you've written in the screen. So what I ended up doing is to now split the names on spaces, right? Because if we look at the names, all the names are split by space. Aditya space Roy. If I split on space, I give Aditya as one, Roy as another entity. If I split Pradeep Kumar Meena on space, I get three entities, Pradeep, Kumar, and Meena, right? So I've done this now using again a single line of code. It just gives me now these four sub-entities because there are certain people who have four elements to the names, right? And now I figure out the first name. I'm just, for the purposes of simplicity, right? This may not be very robust. For the purposes of simplicity, I'm saying that the first name is this first thing which occurs before the space. This may be wrong, but just for the purposes of simplicity. So Aditya, Adya, Akash, Arav, and so on. So now my spreadsheet, my edited spreadsheet will have, actually, let me just run this again. So my edited spreadsheet now has a column called first name, right? Now I'll run the same logic and try to see if certain first names are being repeated or not. I could have done that on the last name also, but again, for the purpose of simplicity for this class, I'm just looking at the first name. And it shows me there are 5 Adityas, but someone said there are more Adityas because there are certain Adityas with double A, right? Certain Adityas with a single A. Again, I could have written a program which matches all Adityas, but for this case, I've just kept the exact spelling. 4 Pranav, 3 Keshav, 3 Patel. That's, so the Patel is generally a surname, but it occurs in certain names in the first, right? That's why I'm saying this is not a robust program. Rahul, Devan, Siddharth, right? So there are a bunch of these names which are repeated, we have 2 instances of each. Now, another interesting thing which we may want to do is, what do you think is the most common character for a name to start with? Do more names start with A, B, C, D, E, F? How many think it's A? Okay, most of you think. How many think it's S? How many think it's P? I, C, E? Okay, so if we just run this analysis, it turns out that most people's names start with A, followed by S, followed by P, followed by M, K, right? So the other interesting thing you can easily do in languages like Python is to create such graphs, right? Again, when you're well versed with the programming language, it doesn't take you long and doesn't take you a lot of code to write to create this count bar plot. A occurs 41 times, S occurs 38 times, so on and so forth. And there are very few names with Z, F, and E, right? But we could have also plotted this in the order of A, B, C, D and just seen the counts. So that might turn out to be something like this, right? We can also very quickly write some code to find the number of people per discipline, right? So some of you might have studied a programming or a language called SQL, right? So this is not very different from what we can do in a language called SQL. For those who've never heard of this term, don't worry. This lecture, again, it's not to make you scared. This is just to show you the power of programming once you can get a hold of it. What are the different kinds of things you can do? You can do data analysis. You can create websites, as I just showed. You can create games. You can create GUIs interface. I can figure out the number of people per discipline. CSE and electrical seem to have more people. Why is that? Because there's an additional program for BTech, MTech, right? Currently introduced. So you can also get a sense of that. Character frequency. So we figured out that the most common character to start a name is A, right? But what is the most common character across any position? A, B, C, D, what do you think? That program turns out to be slightly more complicated than this simple program that we've seen. But it turns out that the most common character is a small a, not a capital A. What does that tell you? So the most common character in this case turns out to be small a, which means that the small a happens somewhere in the middle of the name, not at the starting of the name. Right? So while a lot of names do start with capital A, but the number of small a's which occur in a name is much more common. Right? We can maybe take an example also. So we saw, right? So let's look at the first 3-4 names. Capital A occurs once, small a occurs 1-2 times. Capital A occurs once, small a occurs 1-2-3 times. Capital A occurs once, small a occurs 1-2-3 times. Right? So it just takes you to know good programming, and then you're able to do such analysis fairly quickly. There were a bunch of other things which I could have done, but I'm not doing in the interest of time. And in order to also keep your appetite still a little empty so that you can do this analysis on your own. Not now, but at some point of time, I'm hoping you'll be able to do these things. Any questions at this point? Yes. Any questions? Yes. Can we? That's up to you. So if that is, so you can make some arbitrary choices. You can use the first 2 columns, you can add them up, you can separate them out. All of that is left up to you and the kinds of questions that you want to answer. Right? So that's yet another important thing which I want to pass as a message right away. We often think of computers as the end goal. Many times you think of computers as the end goal, programs as the end goal, but we should also be thinking more importantly of them as a means towards the goal. So what were the questions that you wanted to answer? You start with the questions, you then go ahead and do the analysis or do whatever is required in terms of the program to be able to answer that question. Yes? Other questions at this point? Just one second. Yes. So while I'll come to this later, will we learn only Python or Python SQL interface? You'll just learn Python. It's a very immersive program, and I'm making this clear right at the upfront. We won't be able to do a lot of things which we could have otherwise done, let's say if it were a 16-week program also, because we're limited in time, and we also have huge diversity in the audience. Right? So we'll have to take a stance which benefits the maximum number of people in the audience, which is to choose a subset of things you can do. But more importantly, I think we want to empower you to learn how to learn. Once you've learned how to program, picking up new modules, so some of you might think, why Python, why not C++, why not Java, why not assembly language, why not Kotlin, why not JavaScript, right? So our aim is to enable you to learn how to write programs to develop that logic. Once you learn that, then you can pick up any language on your own. Right? So we can, or no one can teach you all the programming languages or teach you all the possibilities in programming languages, but we can hope that we can empower you to learn the basics so that then you can transfer that to any application that you want. Other questions? Okay. So then let's maybe look at some other cool things which we can do. So how many of you liked calculus in class 11, 12? I'm assuming everyone did calculus, right? All of you did have to do maths in order to come here. Is there anyone who didn't have to do maths? Yes, everyone had to do maths, right? So I used to like calculus, but now it's been a lot of years. It's been more than a decade since I studied in class 11, 12, where I was doing such things. But I like programming a lot. So let's see if programming can help us solve various kinds of calculus problems. If it can help us solve limits, integrals, and things like that. So I create a couple of symbols, N and K. I create an expression, right, which turns out to be something like this. So I've written a program which tells me that I want to evaluate the limit of 1 plus k over n raised to power n with limit n tending to infinity. What is the answer? Sorry? K? E? E to the power k? Yes? Forgotten already? E raised to power k. So if you've forgotten, don't worry. I also forget at times. But I know enough programming to be able to run this in Python and get the answer, right? So this is a very special library called SymPy, which is standing for symbolic Python. You can do various symbolic operations here. You can do calculus, you can do limits, you can do polynomial expansion, you can do things with rational numbers, etc. So various interesting things you can do, right? So this is also to motivate you that many of you are in various different disciplines in the institute, right? So in some of the disciplines, you may want to solve certain problems with differential equations, right? Now, how do you code them up in a computer? Something like this you can do, right? Some of you might want to do generative art. How many of you are into arts? How many of you like drawing? Okay. So let me actually show you. So let's say if this were a painting, do you think this is a good painting or a bad painting? Very good. Let's see another one. What about this one? So none of these is actually a person. All of these are generated using a computer program, right? So these are generated using something known as a machine learning generative algorithm. Again, I don't want you to be bothered or be worried about this. This is just telling you the range of things you can do if you know how to program well and if you studied various kinds of courses, right? So none of them exist. And if you look at all the artifacts, they'll appear to be very, very real, right? So you look at how the hair at the end is also getting using the bokeh effect, right? You actually separating the background and the foreground, right? Now, what I can show you is a simpler Python program, which can create some small patterns, right? So this is a small Python program. It can create patterns like this. So this may, if you make this little more advanced, you can get some cool wallpapers. Right? This wallpaper art, you can create such using the program. Right? And while we're at the discussion of calculus and various things, so does everyone remember what is the gradient of, what is the derivative of sine x? Cosine x? So let's see that. So I'm again writing a very simple program, right? I have plotted this curve called sine of x. Now, without knowing that the gradient of or the derivative of sine x is cosine x, I can again write a very simple program which finds out the gradient of sine of x and then just plot it. So this is d of dx of sine x, which is of course cosine x. Right? So these are various kinds of things you can do if you know how to program well. But at this point, I think I'll also like to make a important point that when we think about computing, we should not be thinking only in terms of a laptop or a smartphone, right? We have computing around us. I already talked about things like the projector. So even a fridge has a computer or it has a program. What do you think? Why do you think that's the case? Or what does that program do? Temperature control. How many of you have heard about the hysteresis? Class 11, 12 physics, hysteresis. In what context have you studied that? Physics, magnetic plasticity, right? Have you studied that in the context of temperature control? No. So the fridge you may not be able to recall, but with the air conditioner, you might see that you have to set a temperature for the air conditioner, right? You set it to, let's say, 25 degrees Celsius. And you might have heard that at a certain time, when the room gets very cold, the AC starts making lesser noise. Why does that happen? The compressor turns off, right? So that's another thing which I wanted to express here. So as engineers, you'll also have to figure out about things around you, right? It's not just the textbooks. How does an AC work, right? It has, even though that may not be your branch of engineering, but the air conditioner has a certain component called a compressor, which turns on and off based on the temperature, the temperature controlled component. So if you set the temperature to 25 degrees Celsius, the compressor will turn on as soon as the temperature reaches, let's say 26. It turns off as soon as the temperature reaches 24. Between 24 and 26, it will remain off. Right? So you can create certain conditions. So this also has to be programmed. What does this program have to measure? How does the AC control work? It has to measure something. It has to measure the temperature. And what does the output from an AC? What is the output from an AC? The compressor state on and off. It tells whether the compressor should be on and off. So it's a program. Right? It's not a program in the sense that you see in front of a laptop, but it's a program which is embedded into a device. What about credit card readers or card readers? What is the input that you give to a card reader? You swipe a card or you place the card on top, right? So they say that does your card have Wi-Fi enabled or not? So you swipe a card, the input of the card reader becomes a certain component of the card. The output becomes that it gives you then the logic or the program which executes is a certain set of instructions. The amount which is entered has to be debited, right? So it's a bunch of things. So this may appear to be very trivial, but there are a bunch of things which happen. That amount needs to be stored, that as soon as you enter the card details, your card reader will have to make a contact with your bank, right? It actually may not make a contact with your bank. It may make a contact through some intermediary service, which makes a contact to your bank on behalf of you. It says that this amount needs to be debited. What happens if something happens in between and the card reader doesn't work fully? What happens? Does it ever happen that the money gets debited from your account but doesn't get credited to someone? So generally, it shouldn't happen. If in certain circumstances, when it happens, the amount has to be refunded back, right? So all of this logic is already embedded into that small device, right? So that's also, in some sense, a very small computer with a certain amount of programming built into it. Microwave oven. What is the input? What is the output? You set a temperature, you set the mode, and then the output is how much coils it wants to heat up at what rate. Various things are happening. Okay. So let me give you a minute to think and tell me what you get reminded by this visual. And don't speak out immediately. Some of you may know the answer. Just hold on to your answer. I want everyone to think. Okay, does anyone have an answer? Okay, yes. Okay, so in popular language, okay. So now tell me the relationship between the previous image and this image. Does anyone know this person? Alan Turing. Who is Alan Turing? Alan Turing was a very good marathon runner. Is that a correct statement or a wrong statement? How many think it's a correct statement? Alan Turing was a very good marathon runner. You think it's wrong? How many think it's right? This person's name is Alan Turing. This person is running a marathon. He was almost record time at that point of time. But he's not known, but he's known much more for computers than he's known for marathon runners. So both the facts were correct. What is the link between Alan Turing and this image? Has anyone watched the movie The Imitation Game? So do you remember anything now? This screenshot is from the movie The Imitation Game, where a young Alan was giving a certain piece of sheet to his friends, which in a language only he could understand, right? So why are we discussing this in a computing course? Do we like movies? Yes. So there was, in fact, another hint which I didn't show here. So there was a machine which the Germans were using called Enigma, in which they were, in common sense, in common language, if they had to discuss. So let's say if you want to transmit this message, see you in 2 hours, something like that, you just offset each digit by 2 or 3, whatever, right? Now this, if you pass into someone who doesn't have a knowledge of what you're trying to do, may think that this is just some random text, some stupid text. There's no meaning to it, right? But if someone knows what you're trying to do, and they know that you have done an offset by 2 digits or 3 digits, they'll be able to figure out that what was the original message that you intended to say. So Germans were similarly translating the message into something which was not very easy to decode on the other end. And that was being broken by Alan Turing and his team during the World War. Right? So that was also the time when there was a lot more innovation about computing and computer science in general. So we're discussing this because we can again write a program to do something similar. Right? Now we won't be writing a very complex program, but first I'll be showing you something called the Python challenge. Anyone here who's heard about this website, Python challenge? No? So let's get started with the game. So it's a game that we'll be playing. I will be playing only the first 2 levels. I am mainly showing this game for people who've already done programming, who may feel that the course is moving at a slow pace and they already know enough, right? So this would be enough to keep you challenged. This would be very interesting exercise. So what do you think I should be doing in order to play this game? Try to change the URL address, and the monitor screen is saying 2 to the power 38. Okay. Okay, so let me try and do what you are saying. That is the wrong answer, but let me still try and do. So he's saying that we should be doing 2 to the power 38. Right? Is that what you say? That's the wrong answer. 1.html. Okay, that's still the wrong answer. 1.html has got nothing to do with this 2 to the power 38. So maybe you want to calculate 2 to the power 38, put that in the URL. Right? How do you calculate 2 to the power 38? How will you write that? How will you calculate this? So 2 to the power 38. Maybe we can write this on Google and it will be able to give us the answer. It says 2 to the power 38 is this number, right? But certain things Google may not be able to parse. And because again, we are programmers, we like to write programs. Let me write a very smallish Python program. So I'll be now running Python in something known as the interactive mode. Again, don't worry. Many of you have not even heard what is Python, and you are being told terms like interactive mode. I'm just showing you that how we can advance to the next level. So I'll write 2 to the power 38. I get this number. I copy this number, go to the URL, and put it up here. And good, we're up to the next level now, right? So what do you think we should be doing for this level? It is showing us an image, K to M, O to Q, E to G. What is the relationship between K to M, O to Q, and E to G? One letter in between, or K, L, M, and then E, F, G, right? So so G is E number of characters of E plus 2. Similarly, Q is number of characters for O plus 2. M is number of characters of K plus 2. Right? So that is what we figured out. But then they give us this kind of a text. Okay, so how will we now change it? Let's say we don't know Python. What do we do then? What does G map to now? I. F maps to? M maps to? N maps to? So H, O, P, then C has to map to E. I hope W maps to? I hope you did not translate this by hand, something like this. We'd expect to get that, right? But then we can write a Python program to do this for us, right? So all we want to do is to take up a character from this string of characters or this list of characters and increase the character by 2, right? But what happens to Y? Does that translate to Z, and what after Z? Nothing. So Z, then again back to A, right? So it has to circle back to A, right? So there's no programming. We'll already know that there is a term called modulo, right? But again, without going in much details, I will actually just show you the output or how we do this program. This is cipher.py. So again, this is a very short program that I've written. I've taken this list of string, whatever was being given in the website, and I am increasing by 2. I'm doing a bunch of other logics, which you don't need to worry about. But let me just show you. I hope you didn't translate it by hand. That's what computers are for. Doing it by hand is inefficient, and that's why this text is so long. Using string.make trans. This should have been a bracket. So there's again a small bug. Now apply on the URL, right? So now the question is, there is a specific URL being given to us, and we want to apply this same plus 2 characters to it, right? So in fact, now I don't even need to run this through a computer because the URL is very short. MAP, M translates to O, A translates to C, and P translates to R. So the next URL becomes ocr.html. But then they've given a hint that you could be using string.make translation table, right? Something like that we can be using. So I'll show a shorter program for this. So this is the shorter program. Right? So in a shorter program also we're able to do this. So what we essentially say is that there is an input set of strings A, B, C through Z, and this is mapped to C, D, E through Z followed by A and B, right? Again, if you know program well enough, you should be able to use very few lines of code and be able to get this done very efficiently. I didn't have to type A, B, C, D myself. I just use certain things which are available in Python. I picked up all the lowercase characters and I did a bit of manipulation. Again, you don't need to worry about this, but by the end of this course, I would expect you to be able to do problems like this on your own. Okay. But at the outset of the course, I would still expect people who already know programming. Once you've figured out everything in the course, you've done everything in the course, like you've done the assignments, the other aspects of the course, then you should be having this fun, not before that. I don't want you to be missing out on grades. Coming on to grades, I don't know if many of you know this or not, but there's a possibility to get a 11 on 10 also. Do you know that? Yes. So there is an incentive for many of you to try and get an 11. Right? So don't think that if you already know programming, you should be able to get a 10 very easily. First, it may not be very easy. Second, there is a possibility that you can aim for an 11. And I think if people work hard enough, even if they've not done any programming previously, they should still be able to, there's still a possibility of them trying to get an 11 on 10. So we saw this program now, and if we actually move on to the next, I am now actually not going to solve this for you, but there's a hint. You need to open the source code of this page. So you'll have to go and show page source, and then you should be able to solve this. So it's a fun exercise. Similar to this, there is a website called Project Euler. Right, so this Project Euler again has certain mathematical programming like questions which you can solve. I won't recommend them to beginner level programmers. I would recommend them to people who are very well versed with programming and they just want to have some additional challenges. So maybe let's pick up a question. I've already solved this, so the answer appears. If we list all the natural numbers below 10, which are multiples of 3 or 5, these are 3, 5, 6, and 9, and the sum of this is 3 plus 5, 8 plus 6, 14 plus 9, 23, right? So if the question was all natural numbers below 10 means do not include 10, right? Below 10 and find the sum of them, it is easy to do by hand. You can figure out that the answer is 23. If you have to find the sum of all multiples of 3 or 5 below 1000, right? Can you do this by hand? How many of you think you can do this by hand? So actually this question is also given to you on purpose. So thus far I've been leading you to believe that computers can do a lot of things for you. That computers are very efficient, boring things can be automated. You should be using computers everywhere. but this problem can actually be solved by pen and paper in matter of milliseconds, right? But let's look at a couple of ways to do this problem, right? And then I'll show you the Python program for that also. So I'll try and share my writing screen here. Is the content visible? Okay. So we're looking at the numbers from 1 through 10, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's do a simple procedure. We go through each and every number and we see whether a number is divisible by 3 or 5, right? So I'll just circle those numbers. I start from 1, divisible by 3 or 5? No. Divisible by 3 or 5? No. Divisible by 3 or 5? Yes. Divisible by 3 or 5? No. Divisible by 3 or 5? Yes. Divisible by 3 or 5? Yes. Yes. And then I go through all the circled numbers and I add them up. So 3 plus 5 plus 6 plus 9, right? So below 10, sorry. I meant lesser than 10, right? All the natural numbers lesser than 10, whose sum is, we're trying to find the sum of these numbers, right? This is one such way to do. This is a very natural way in which computer programs will think about this. So is there a better way to do this? Sorry? DP. Arithmetic progression. So again, don't tell me terms, tell me a way to solve. Because terms may be, so you may know the answer, you may know the term, but someone else may not know the term. Can we just figure out all the multiples of 3, right? What are all the multiples of 3? 3, 6, 9, all the multiples of 3 which are lesser than 10, all the multiples of 5, right? And then all the multiples of 15. So this is actually not a very good example. Let's do this till 20, right? All the multiples of 3, 3, 6, 9, 12, 15, 18, all the multiples of 5, 10, 15, and we're doing till lesser than 20, right? Do we see that 15 gets repeated? So can we find out the sum of all the multiples of 3 plus the sum of all the multiples of 5 minus sum of all the multiples of 15, right? Why is this a better algorithm? Why is this a better way to do than look through all the numbers? One, you don't need a program to write this, because at this point of time, you're basically saying 3 of 3, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 into 1 plus 2 plus 3 minus 15 into 1, right? What is the sum of first n natural numbers? N into n plus 1 by 2. You can apply that formula here. You didn't need a computer. You could have solved this just using plain pen and paper. Right? So that is why this was also a trick question, that when you think about programming, you shouldn't be forgetting about all the mathematics that you studied. There are always better ways to solve the problem. Now we can, again, if I had to write a program to solve this, I could have seen all the numbers which are divisible by 3. Again, don't worry about the syntax or what all the gibberish things which may appear to you if not done programming earlier. So this is saying that is a number divisible by 3 or not? Is a divisible number divisible by 5 or not? If the number is divisible by either 3 or 5, you add that number up, which is what we did. That is one way to look at all the possible numbers till 1000 and then see if a number is divisible by 3 or 5. The other method which I said is you look at all the numbers from 3 till 1000 in a gap of 3, 3, 6, 9, 12. All the numbers from 5 till 1000 in a gap of 5. Sum of all of these numbers, subtract the sum of numbers which are multiples of 15. Right? This is a far more efficient way to solve. And we can also see this actually. Let's So I'm just showing the timing comparison of these two methods. So the method M2, which was using the sum of all of these numbers minus the sum of multiples of 15, turns out to be much quicker, right? So can we limit the discussion, please? You can do the discussion later, please. It's disturbing the others. So there are, again, certain kinds of such questions which are present on Project Euler. This is for people, again, who want to be challenged. This was an easy question. You can look at a lot of the other questions. There are a bunch of such questions. Yes. Can you speak a little louder? You could have taken there are various ways to do that. I just wanted to show that there are methods you can use to solve. I don't want to be getting into the specifics because that's not for this lecture, that's for the future lecture. This was just to show that there are various kinds of things which are possible when you know how to write programs. So I'll first now go through some elements of the course logistics, and then we'll come back to what is known as computational thinking. We've already done a bunch of computational thinking, but we'll just formally define a few terms. So we just go to the course website. So all of you are already aware of the course website. There are a couple of instructors. All of you would have received a Slack invite. Is there anyone who has not received a Slack invite, who's not active on Slack? Not received? Okay, so those who have not received a Slack invite, please meet me after the lecture. We will add your email IDs. Everyone here has figured out how to use Slack? Yes? Yes, no? Someone said a no? I can show you quickly what it's supposed to do. So let's say that, so this is the channel that you're seeing on Slack, which is all members, right? So I'll be posting various instructions, discussions here. And for example, I yesterday posted that we'll have a first lecture here. So I'll be posting things like what are the different sections that you have. I'll be posting things like if you have an extra lecture about quizzes, assignments, etc. I'll be posting here. That's it. So it's just think of it as a communication medium. I want you to avoid email here because it gets very difficult to maintain emails across this huge set of students. We'll also be dividing you into different sections and subsections. So it just makes it convenient to have your own section put here. Right? You can just talk to your colleagues in that section. The teaching assistant for your section, for your subsection can reach out to you and have a discussion. Any question about Slack? The timings of the course are Monday to Friday, 11 to 1, right? And certain days we may not have lectures. Certain days we may have to account for some additional lectures. Sometimes it may be on a Saturday. We'll let you know. Given that we have a very short time and we're still going to figure out the different backgrounds of the students. So we want you to do well in the course, which means if we have to arrange for extra lectures, extra tutorials, extra sessions, we'll have to do that. We'll have labs on Mondays and Wednesdays for section 1, 2, 3, and 4. And section 5 will have on Tuesday and Thursday. We'll define the sections soon. We'll probably send them out today. Right? Sorry? No lab. So there is no lab today. The labs will start from Monday. Why are you happy? So no questions about the lab? Generally, the question I get about the lab is, do I need a laptop? Do I need a phone? Do I need internet? Do I need to know programming? Do I need to wake up? Do you need to wear a hoodie? Any other question? Yes? 108? Yes. 108, 109, 7108, 7109 are the computer labs, which are right near to the place where you have the beautiful paintings being done, right? So you can remember that. You'll have, yes. The sections will be divided, you'll get to know soon. Sorry? Replit will come to it. Other questions? If you have a laptop, you prefer to do on your laptop, you should bring your laptop. Otherwise, you can use the lab computer. So having a laptop is not necessary for the course. If you have a laptop, you can make use of a laptop. Otherwise, you can just use the institute resources. Of course, this course requires a lot of practice. So if you don't have a laptop, you may want to go to the lab often, even beyond the lab hours, even beyond the lecture hours, to use the lab. You're free to use the lab until unless there's a lecture going on at that point of time. There are also computers in the library, I believe, right? And in the worst case, if you're still not able to get hold of any resources, please reach out to us. Right? So that's the most important thing I want to say in this course. If you have any difficulty, please reach out. Right? It's a very short course. We don't want you to be coming midway and saying that there were certain problems. That's why you couldn't do well in the course. Right? If you don't get a good start, the course is so short that you'll have a really hard time catching up. And the next set of courses also started only in a few days after this course ends. If anyone has language issues, please come up to me without having any reservations. Right? We will try and accommodate you in whatever way possible. Right? We will arrange extra sessions. We will have people speak to you in your own language. Right? We'll do whatever we can in our capability, but we do need you to come out to us, to reach out to us. Other questions about labs? Where should we reach? Yeah, I'll just come to that. So I've kept these office hours, and we'll have to modify this as time goes on based on how the response is. So Monday, Tuesday, Thursday, Friday, 3 to 3:30 p.m. Again, I am open to modifying this in case we need more or less in my office. So this is walk-in without any appointment, right? So don't write me an email, don't write me anything on Slack. Between these times, you can just drop in my office, Academic Block 6, 407D, right? Other questions about the labs, about the lecture timings? Course plan will come to it. Yes. First, let's go to the grading policy, right? I think that's what you were mostly very eager to hear. Right? So we'll have worksheets. We'll have 8 worksheets. Given it's a 4-week course, roughly 2 worksheets a week. Some weeks may have 3, some weeks may have 1. So worksheets will be questions which will be given out to you in the class. At what point in the class, I can't comment. I won't be able to comment that. At some point in the class, we'll give you worksheets. You'll have to solve them and give us back the same time. They'll be graded soon and you'll be receiving their marks. So these are questions which will be given to you in the lecture hours. You have to solve them and you have to give them back the same during the lecture hour itself. Any questions on that? We'll come to that. Any question about worksheets? So we'll have 8 worksheets, but we'll take the best 6 out of 8. So that ensures that if you have a bad day, if you have to skip due to certain illness or any other issues, you're still able to get a better chance of making good grades. Programming assignments, we'll have 4 assignments of 6 marks each. So each week you'll have a programming assignment. So what is you have to solve the worksheet. They will be, so in the worksheet, you will have, the question is what do you have to do in the worksheet? The worksheet will have questions on similar lines as we're doing in the lectures and in the labs, but they will be written questions. You have to solve them and they will be graded. Programming assignments, there'll be 6 marks programming assignments, 4 such assignments, and you can do them at their own time. But we'll have, this is a tentative timeline for the programming assignments. First assignment, 28th November, it will be released, due on 5th December. Second assignment released 5th December, due on 10th December. Third assignment released 10th December, due on 14th December. And third assignment released 14th December, due on 19th December. There will be a mid-semester exam and an end-semester exam. The mid-semester 12% marks 8th December. And end-semester 16% marks 23rd December. Any questions on the grading policy? So all of that is for the regular semester. This is not a regular semester. As such, you have much more than 3 exams. You have an exam every alternate class in some sense, and then programming assignments, and then you have mid and end semester exam. Other questions? When? Yeah, we'll let you know. So the question is, will the worksheets be surprise or will we let you know? At least initially we'll let you know. And then we'll have to see on the response, what do we need to do, right? As such, because there are not a lot of classes, you get some pattern out of it when to expect some worksheets. But you should be studying regularly, right? If you miss even one class, it becomes very difficult for you to then compensate. Other questions? Do you need to solve the worksheet in the class? You need to solve the worksheet in the class as if it's a timed exam. So it is a timed exam. You have to solve it in the class. You have to give back the answer sheets. They'll be graded soon and given back to you. The assignments will be given over a platform called Replit. I'll come to it in a second. Yes. We will try and notify you at least 1 or 2 days in advance. We will not notify you 5 minutes before. Try and notify you sooner. For the lab, why is that worry? So the question is how the section is divided. So why is that a worry? Firstly, I'm trying to understand. Sorry. Okay, so we haven't actually decided the policy yet. So we haven't done the division, but we will let you know soon. What will be asked in the exam? You'll get to know on the day of the exam. But okay, so on a serious note, so I'm coming back to also some of you are asking what is the textbook you should be using. So there is as such no prescribed textbook. Whatever is being discussed in the classes and labs, you have to think the questions would be similar on similar patterns. Right? There may be a slight difference in the difficulty of the questions, but if you've done the classes well and the labs well, you should be able to do a good job in the exams. Little louder, please. If you miss what? Miss any what? The recording will be available. Please do use recording as an aid. Please don't use it as a way to miss the lecture, right? Because if you do that, then our hands would be tied. You may never know when we change the policy to surprise quizzes, to surprise worksheets, right? So please do try and attend the lectures. They are more for the case that, let's say if there were certain things which you found difficult in the class, you can always go back to the recording. If there's certain things which went a little quicker, you can go back to the recording. Or if you're having some language issues, you can go back to the recording. Please use that wisely. Please don't use that as a proxy for not attending class. We'll get you'll figure out all these things about the recordings in due course of time. So most of the things would be made available to you over Slack, over the website. We'll let you know. Yes, other questions? Yes. So do we need any textbooks? No textbook is needed. The course content plus the Python official documentation should be more than enough. And in many cases, in fact, we recommend you don't search the internet for various things. You may end up picking up wrong ways to do the things, which can then in the long run be harmful, right? There are various avenues in which you can ask questions if you want to ask. There, as we discussed, there are labs, there are lecture hours, there are office hours. There are going to be TAs assigned to you. So there are multiple avenues given to you, but no specific textbook is prescribed for this course. Yes. So the course syllabus will be covering various modules and topics in Python. Some of you who have not been exposed to Python and programming may find these terms a little weird, but those who are, I think this question is immediately for them. We'll be talking about things like variables, expressions, conditionals, then loops and iterations. We'll be talking about strings. We'll be talking about strings, and then different advanced data structures such as lists, tuples, and dictionaries. We may end up doing 1 or 2 additional data structures and object-oriented programming in case we have time, right? But this is the main set of content. Little louder, please. Will we study Django or not? No, we will not study Django. But again, if you do the course well enough, you should have enough confidence to pick up new things like web frameworks. You should be able to do them on your own. In this course, we will not. So I'll make this explicitly clear. We are not here to teach you gazillions of libraries and tools and modules and languages. We want you to embrace the philosophy of how to program, how to think computationally, and give you a certain set of data structures and key programming constructs, which you can then use to build on and solve various problems. So use this as a base, and then you can launch to various kinds of things you want to. No, the graphical thing which was demonstrated will not be taught, but again, the point remains the same. You should be able to pick that up if needed. Will you just, so I would say just wait for the specific modules to be introduced, because again, the questions will help you to answer these. Like when we give you the questions, you'll understand that the focus is not again on specific modules, it's on learning how to program. So whatever is needed for that, we'll have to learn that. Yes. The PDF of the syllabus. So the syllabus will be put on the course website. Semester wise. Okay. So the question is, what is the semester wise course breakup? So many of you have, so all of you would have an assigned faculty advisor, right? This question is should be directed to them, because this syllabus is for the respective branches is decided by the respective branches. And so this particular course is this semester course only. This will just end in 4 weeks. Are you asking about how the division of the 4 weeks is done? So, okay. So we'll put that up in a day or two. We'll put that up, that what is the tentative way in which we'll proceed with the course. Yes. Do you need any software? So I'll just show how to use a particular website called Replit. And I'll show that you actually need nothing else. Okay. So someone is asking about what kind of an editor you should be using. That's totally up to you. In this course, because it's an introductory level course and we have very less duration of time, we'll be using Replit, which is a web-based integrated development environment. I will now just move on to that. So previously I was showing certain programs, right? So let me again write another program. So this is the program that I've written. Right, so it's a full-fledged simple program that I've written on this website called Replit. So we have shared the link for Replit on the Slack channel. So if you've not already done so, please click on this link and sign up on Replit. That way you'll end up in the IIT Gandhinagar computing course. So if I come to this course, I can then see who are the members. So I see currently 191 members. There should be about 330 odd members. So about 140 of you not yet signed up on Replit. If you're facing issues, again, come to us, or we'll have some TAs look into this. But just sign up on Replit using the link given to you. We'll be using Replit as the web-based environment/editor for you to do programming. Can you do programming using PyCharm, Visual Studio Code, Eclipse? Yes, you can. But for the purposes of consistency, simplicity, we'll just recommend that if you've not done programming at a fairly proficient level before, please stick to Replit. That will provide a common platform so that the teaching assistants and the instructors can make it easy, can have a easy time in helping you debug your programs, correcting your programs. But can you use Emacs, Vim? Yes, please go ahead. Yes, other questions? How do you use Replit? So I have just signed up on Replit. Right? This is showing you after I've logged in, and we'll be giving you links to certain questions. Right? So you can, in fact, if you just want to play around and not go to the specific question that we have given, you can just go to create and just write Python. And let's just give it some name, class demo. So it will load up the Python environment for you so that you don't have to install anything. Right? So that was one of the shortcomings before such web-based integrated development existed. You had to install certain things locally, or you had to create a cloud-based environment in which we would have a common set of resources. I think the internet is down for some reason. Okay, so this is potentially happening because a lot of us are signing up on Replit at this point of time. So maybe we're getting rate limited, but we'll share some resources on this. So we'll have in the lab sessions also, we'll have live demonstrations of how to use Replit and how to code and the various aspects of coding on Replit. We'll soon see that. Yes, other questions? Yes. From where do you get? So this recording will be put up. I'll let you know on Slack. I'll make the announcement. As soon as the recording is ready, we'll put it up on the course website somewhere. Right? So all of the resources would be made available in due course of time on the course website. Yes, other questions? Sorry. So apart from Python, what are we going to learn in this course? So I'll reiterate my answer. So we're using Python as a means to help you learn how to program, to develop computational thinking and methodology. Python is only one language which you're using. But if the question is, so you're mainly learning those things using Python. You're learning how to solve problems, to learn different programming constructs. So whichever language you use, you'll end up using things like loops. You'll end up using things like conditionals. You'll end up using things like various kinds of data structures or data types. So all of that is common across languages. It's only the way in which you say the things, right? So for example, many of us, maybe now we presently conversing in English, but we could have given a very similar introduction to programming lecture in, let's say, Spanish, right? The computational aspects might have remained the same. It's only the medium of communication which might have varied. Similarly, we're using Python as that language, right? But the programming construct methodologies, the computational thinking aspects will remain the same. But if the question is, are we learning C, C++, Java, etc.? No, we're not learning that in this. Yes, other questions? I can't hear you. You'll have to be very louder. So, okay. So the question is that in the future, you'll have various kinds of courses. Will Python be sufficient for all those courses? There is a small subset of courses which requires you to learn different languages, other languages. And again, the hope is that if you learn Python well, you should be able to pick up those languages. Some of the other courses may be covered in the other courses, or some of the languages may be covered in some other courses also, as and when required. Is that correct, Balgopal? Is that correct? So we'll focus on Python only, and other courses which require other languages, C, C++. We'd expect the students to be able to pick that up, or we'll have certain other courses which cover them. You're not audible. You'll have to use the mic. Hi. Am I audible? Hello. 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 Meantime, are there other questions? How will the assignments will be given to again on Replit. So you'll be given certain URLs, and the Replit ID itself will allow you to submit assignments there, and they will get auto graded, and we'll get to know your marks. So don't worry about that. We'll cover that in maybe the next lecture on the labs. How does Replit work? How do you submit your assignments? We'll cover all of that.
Hi. Am I audible now? Okay, so I am Balagopal, the other instructor. So regarding this question about other languages. Hello, check. Am I audible now? Am I audible now? Okay, so I am Balagopal, the other instructor. So like Nipun said, the point of this course is not to learn Python, right? So that would be the wrong approach to learn programming. The point is to learn programming. It is just that we are using Python as the medium, right? So this could be confusing. So there are many different natural languages, right? English or German, Hindi, Spanish, and so on. And let's say you know English, it is still somewhat very difficult to pick up a different natural language. It takes a lot of time. But luckily, we don't have this problem with programming languages. So once you learn Python, the effort to pick up other languages, let's say JavaScript or C or whatever, is not as high as picking up German once you know English, right? So programming languages are much easier to adapt to. So this means you should try and understand the core programming concepts. And during, so if you are doing a BTech CS, especially, you will be expected to pick up many different programming languages. And I think this is true for even for people from other departments. For example, I know some people use MATLAB, some people use Macaulay, and so on. So there are hundreds and thousands of different programming languages, and no course or no program can be expected to teach all of them. But the goal is to get to a sufficiently high level so that you can pick up things on your own. And why do we have different languages? Because for different things, we have to use different tools, right? So the programming language to write web apps is JavaScript, or it is the most popular language. It is basically the language of the web. And if you, in the future, if you do a data structures and algorithms course, we will be doing mostly in C or C++, right? But don't worry about it. If you understand the core programming concepts, you will be able to pick up any language very quickly.
Yes, other questions? Yes. Yes. So from the next lecture onwards, I request all of you, please come up on reach here on time. If the time is 11 AM, please reach here on 11 AM, right? So otherwise the class starts slow and late, and then it creates a problem. Some of you come up on time, some of you don't come up on time, and the attendance, all of these things, they get delayed, right? So please do come up on time from tomorrow onwards. Other questions? I'm surprised there's no question on what should we do to score well in the course. Sorry? How to get the 11? So to get the 11, you'll have to do well in across all aspects of the course. You'll have to be consistent in the classes. You'll have to submit all the assignments. You'll have to do well in all the course sheets. That is possible only if you're very consistent and you have to work hard in this course. There's no shortcut around it. So like most new things, programming can be hard at starting, but if you keep up with it, you will be able to do well. Yes, other questions? Yes. Okay, the question is that there are no prescribed textbooks for the course. How should you prepare for your exams? So this is how we want you to get out of that mold of certain textbooks being the way to study. So whatever we cover in the classes, you'll see that that is more than sufficient to do well in the exams. So you don't require any textbook, just go through the class notes, make notes. If required, go through the recording, go through the slides, go through the code. That should be enough for you to pick up whatever is needed for the course. There is no need for any specific textbook as such. So the slides, we will not be using slides mostly for this classes, but we'll be sharing the code. So we will be sharing the code which we will be using in the course. Today's slide I'll share, but they're not that instructive as such. There's nothing much you can revise in these slides. So people who already know Python, we will always have some questions which should be there to challenge them also, right? So we'll have those questions as star mark questions. Those questions should challenge everyone, in fact, right? And I just want to pass this message very clearly. Just because you think you know Python doesn't mean that one, you go about, you just start missing lectures or you become casual. And on the other hand, I am very sure that people who work hard, as you saw, we solved a few programs. We solved that multiples of 3 and 5, which are less than 100 or 1000, right? So if we figure out the logic, if we figure out the logical steps, we should be able to write good programs. So people who have not done programming earlier, you should still be able to do well. There's other questions? Yes, any other question? So some of you are having issues with the biometric attendance. Just try it out for one or two times. If it still doesn't work, you can just raise your hands and one of the TA will just note down your name, and we will figure that out later. And in the meantime, just pass on the machine to the neighbors so that we can still efficiently do the attendance for everyone. And we'll note down your name. We'll ensure that you get registered in the platform. So while we're still doing attendance, while I plan to end at this point, but because we're still doing attendance, we can just do 5 minutes more of discussion. So we discussed that the goals of the program is to develop the computational way of thinking and then use Python as a means towards that. Let's look at some aspects of what we say is computational thinking. So we'll be talking about decomposition, pattern recognition, abstraction, data representation, and algorithms, right? So none of this has got to do specifically with any programming language, but let's see. So let's say if I were to ask you this question, write an essay on your JEE experience in 5,000 words. How will you go about this? I'm not asking you to write it right away, but how will you go about writing an essay on a JEE experience in 5,000 words? Anyone? You can raise your hand. Yes. You create bulleted points. You think about, you create bulleted points. You, in your head, you create, these are the main components, and then you go about it, right? So that's the other thing. You'll have to be very smart about just looking at the title. It already said decomposition. Right? I was expecting the answer that you are able to decompose the problem into smaller problems, right? So we are already doing this. If you want to write an essay, we create an outline, right? You figure out that maybe the outline is background to class 10, schooling subjects in class 11, 12, lessons, your experience, your whatever subjects you liked, how was your exam, what happened after the exam, right? And then you can figure out that maybe how many days you want to give to each, how many words you want to give to each, right? If you got a bigger problem, you have divided into smaller problems, and then you can work on each of these pieces. So we'll be doing the same things when we're thinking about programming or computer programs. We'll take up bigger problems, divide them into smaller problems or problems which you already know how to solve. Second is pattern recognition. So imagine if you were to do assembly of a piece of furniture. This is very common in IKEA-like products. So let's say that it takes you 1 hour to assemble the bottommost piece, right? So will it total take you, there are 1, 2, 3, 4, 5, 6. Will it total take you 6 hours to assemble this or lesser hours? Why? Because once you figure out the pattern for the first one, the next time it becomes easier, right? So that's the same thing which we'll be using. That can we use patterns which are already known and then reuse them in our future aspects of the program. Adding 1 plus 2 plus 3 plus 100. So who do you attribute